Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using Go programming. So let's look at today's question. Max number of k sum pairs. You're given an integer array nums and an integer k. In one operation, you can pick two numbers from the array whose sum equals k and remove them from the array. Return the maximum number of operation you can perform on the array. Okay. So let's go to the drawing board and see, understand the question and see how we can solve it. Okay. So this is the array nums 1, 2, 3, 4 and k is given to us as 5. So as the question tells, we need to find the pair of elements which equals 5 and then eliminate it from the array, and we need to find how many such pair exist in this array. So let's start doing it. 5. So if you can see in this array, 1 and 4 together will give us 5. So that is one pair. Sorry, res will define is equal to one pair, and then we eliminate that from the array. And then 2 and 3 together, 2 plus 3 gives 5. So, and that is one more pair, 1 plus 1, 2. So res is totally 2, and we eliminated that from the array. And there is no more elements in the array. So res is equal to 2. I hope you understood the question, and let's also do one more just so that you understand it much clearly. Nums is 3, 1, 3, 4, 3 and k is equal to 6. So now 3 plus 3 gives us 6. So this is one pair. We eliminate it from the array. And now there is no other pair which gives you 6. So total result will be 1. Okay. Now that you understood the question, let's see how we can solve it. So let's write down the question 1, 2, 3, 4. So first I will tell you there are multiple ways of doing it. First let's see how we can do it in a brute force way. How can we do it in a brute force way? So for each I, basically for each I, so if you have 1, 2, 3, 4, if your I is at 1, go have a j and go to all the rest of the element and see 1 plus what will give you 5. You will find 1 plus 4 gives you 5. So res is equal to 1. And then I will be incremented. So I will be at 2. For 2, go to again j rest of the array. So 2 plus 3. Yeah, 2 plus 3 gives you 5. So increment your s to 2. And then 2 plus 4 gives you 6, so that won't work. I is 3, 3 plus 4 doesn't work. And for I is equal to 4, there is no j, so nothing else works. So if you follow an approach like this, that will be n square. Can we do better? Let us see if we can do it better. Cancel this. Again, take the example 1, 2, 3, 4. What is another example? Other example is whatever array is given to you, sort it. Sort the array. In this case, the array is already sorted. So let's just take the same array because it's already sorted. If the array is not sorted, first step you should do is sort the array. And then if you've seen my previous video, we had used this technique called two pointer. Let's use this. One pointer will be at the beginning of the array. One pointer will be at the end of the array. Now add these two numbers, 1 plus 5. It is equal to 5. So this works. So if 1 plus 4 is equal to 5, increment your res. So res will be initially 0, it became 1. And then if we found a pair, increment both, because we shouldn't consider that pair again. And then you have 2 plus 3. 2 plus 3 is also 5. Increment res. And then we do this until there is a condition L is less than R. Now once you found a pair, you will increment both L and R. Now when L and R becomes equal, this condition exits. So in total we found two pairs by this two pointer approach. But here, since we are sorting, time complexity will be n log n, which is also not very efficient. Let's see how we can do much more better. So how can we do this in a much more optimal way? So we know the result. K should be 5. That much we know. K has to be 5. Now, for each element I, for 1, how much you should add to get 5? You need to add 4. So, if we know that 4 already exists in the element, that means we know that there exists a pair, right? Similarly, for 2 also, 2 plus what gives you 2 plus what, x is variable, what 2 plus what gives you 5, x is equal to 3. So 2 plus 3 gives you 5. So if we already know that 3 exists in an array, or in an array, we know that there exists a pair which is 2 and 3. So knowing this concept, let's see how we can use a data structure to achieve this concept. So let me explain the approach first, and then I'll dry run it, then you will understand the approach. So let's assume you have an hash map of key will be element of this array and value will be frequency. Why do we need to record the frequency also? Because in this example every element occurs just once, but there can be an array like this also, 1 1 1 3 2, in which case an element can occur more than once. That's why you need to record both key and value. I hope you understood that. So now we are recording both key and value in the hash map. Let's assume you have an hash map. So how do we use this hash map? So traverse through each element of the array first. Traverse through each element of the array 1. So for 1, what is required? Find x. 1 plus what is equal to 5? X is 4. 4 is required, right? So check if 4 is in the hash map. Currently, let's assume this is our hash map. There is nothing in the hash map. It's empty. So if your hash map is empty, that means there is currently no pair found for 1, because 4 is still not in the hash map. So add 1 into the hash map because we still haven't found any pair to it. Add that and move on. So I will become 2 now. I is at 2. Now 2 plus what gives you 5? 3. Is 3 in the hash map? 3 is not in the hash map. So add 2 because we didn't find any pair for 2. And then move on. Move to 3. Now 3 plus what gives us 5? 3 plus 2 gives us 5. Is 2 in the hash map? Yes, it's present. So that means we found a pair, 3 and 2. We found a pair. So increment your res. Res initially will be 0, it becomes 1. And then don't add this 3 into the hash map because they have told you need to cancel those elements if you found a pair. So if you add 3 into the hash map, you will end up counting repeated pairs. So don't add 3 into the hash map, just count the result and move on. So move on to 4. So again 4 plus what gives you 5? 1. 1 is also present in the hash map. And also one more thing, this 2, since it became a pair, we need to remove it from the hash map. That's also a very important point. So this 2 was previously found in the hash map, so we need to remove this. Then again coming back to this iteration, 4 plus 1 gives you 5. 1 is in the hash map. First remove 1 from the hash map and then count this pair 4 comma 1 2, and then I moves out. So our final result will be 2. So by doing this, we just did it in a single pass. So we have a time complexity of O of n. Since we are using hash map, we also have a space of O of n. Okay, that's how hash map reduces the time complexity from n log n to O of n. I hope you understood the solution. Now let's just go back to the editor and write a code for this. Okay, so how do we solve this? First, initialize a hash map. Hash map. So make is used to initialize a data structure in Go. So map key is of int type, value is of int type. Now, as I mentioned, loop through nums. This is one of the ways in which you loop, wherein the first position is the index, which we don't need in this case, and second position is the value. Now let's find the complement value. Complement is nothing but the x that I was talking about. So that is nothing but k minus n. Okay. Now frequency comma okay is equal to hash map of complement. Okay, this again has to be like this initialization. So OK will give you true or false based on whether complement is present in the hash map. Frequency will give you how many times it occurs. So if frequency of that particular complement is greater than 0, so basically if that particular element exists and frequency is greater than 0, which means it exists, then what should we do? Increment res. So first define it. Res is nothing but result, initially 0, and then decrement that complement as I mentioned. Hash map of decremented. If it is not present, add that particular n into hash map. Okay, and at last we return res. Now let's see if this works. Okay, what is the issue here? Oh, the syntax is wrong. It has to be okay. Now let's check. Okay is declared and not used, so make it underscore because we are not using it. Okay, yeah, works. So as I mentioned, the time complexity is O of n because we are looping it only once. Space will be O of n because we have an hash map. I think you understood this hash map logic. It's fairly simple. If you have any questions, comment down below. Please subscribe. Thank you so much for watching.